Good evening. Get some focus up in here. There we go. And then I guess we'll have to fix this part yet again. So one day I will learn to first check before starting streaming. Hi, good evening. Yesterday I was doing or giving slalom lessons, so couldn't do live coding. But luckily there's today. I heard from a couple of friends that this one is a doozy, number day 3. So yeah, we will see about that. Let's get cracking. We've got our environment set up, I believe. Yeah, let's check this out. Yep, it's not yet in presentation mode, so let me fix that real quick as we read the assignment. So we were on a submarine. We already did some scanning. We already also did some command parsing and moving around and stuff. And now on day 3, there's a binary diagnostic. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. That diagnostic report consists of a list of binary numbers, oh boy, which when decoded properly can tell you many useful things about the conditions of the submarine. First parameter to check is the power consumption. And you need to use the binary numbers in a diagnostic report to generate two new binary numbers called the gamma and the epsilon rate. And the power consumption can then be found by multiplying the gamma rate by the epsilon rate, okay? And each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. For example, given the following diagnostic report, considering only the first bit of each number, there are 5 0 bits, so that's 1, 2, 3, 4, 5, and 7 1 bits. Since the most common bit is 1, the first bit of the gamma rate is 1. Okay, and the most common second bit of the numbers in the diagnostic report is 0. So the second bit, okay, yeah, so you just check on the indexes, I guess, what the most common numbers are, or number bits are basically, and then compose a new bit number of the same length. And then that would be the gamma rate. The most common value of the third, blah, blah, blah. Okay, and then, oh shit. 22 in decimal. How does that work again? Is that 1, 2, 4, 8? I don't remember. So this would be 16. So we've got 2 plus 4 is 6. 2, 4, 8, 16. Yeah, 16 plus 6 is 22 indeed. Okay, nice. The epsilon rate is calculated in as a... Cheers. Thanks for the confirmation. I need that kind of stuff. So that's gamma rate. Then epsilon rate is calculated in a similar way. We just need to use least common bit instead of most common. Okay. Oh boy. And I think I already looked at it a little bit. So these are 5 bits. But the puzzle input is not 5, but 10, I think. No, it's even more. So this is 5. It's 12 bits long. Okay, let's copy paste this, or copy this already. And then let's get our day 3 thing going. Let's just immediately put a new class there or something. Do it a little bit different than usual. Put it in day 3. Yeah, day 3. That's already the class file, or that should be the class file. Or production, I mean. Then same for the tests. So we can just go from here and then do Command-Shift-T on that and create a new test. All right. And then we'll create a test that says something like can solve one or something. Solve one produces gamma and epsilon bits. Why is it going so slow? Maybe I'll do test input or something. And then we'll do the actual input. And that input we keep in the resources. So let's create a new file. Day 3 actual input.txt. That would be this. And then maybe let's do test input.txt. And we'll put the other stuff in there, this part. Voila. Okay, so if we do day 3 / test input.txt, we'll read those lines. And we'll say input. And we'll need to import that stuff, and then we'll say solve one of day 3 maybe. What I think I want to do is actually have those two numbers be produced, and then we'll multiply them in here. No, it wasn't 22, it was something else. It was 22, and maybe we can do that first. So assert that gamma is equal to 22, and then epsilon is equal to some other number, 9. And this would be 198, okay. Let's just do a pair of int or something. Should be okay, huh? Ah, I didn't know that. Okay, we'll put day 3.solve one in here. And we'll do a list of strings, and we'll output a pair of int, and this should return 0 to 0 or something. Should be okay already, huh? There we go. Then maybe what I want to do, because it's a lot of list operations as usual. So what I was thinking about doing this time is starting up a read eval print loop and get some output that way. And we've got our unit tests right here, I guess. So maybe let's just try it that way first. So if we start a new one, And I think you can say that it should take into, oh my. If I use a class path of test, then I can do everything, I guess. And the tests are running, that's cool. So let's do the day3 slash test input.txt, and then maybe I can do read lines on this. Yeah, that's cool. And then we can already just start playing around with that. So if I want to take the first, I think what I want to do is count the ones and count the zeros or something. So maybe is it count by something like that? So count where I want the first character of the string to be a 1 or something like that. Oh. Ah. Ah, okay. So the double equals is correct. I need to compare to char. There you go. I did expect this to output something though, right? Can run this with Command Option W. Let's go. See what this produces. Absolutely nothing. Don't know what that does. I wonder why it's not working though. Maybe we cannot find something. That's the reason. Let's see if when I do that, what do I get now? Also nothing. Could not load file. That's cool. You can do split or something. Wait, now I get the actual error though. So if I revert that, and I run it again, how can you refresh that stuff? Clear results. The problem is that it's not doing anything, eh? Fucking hell. Okay, if I do also... okay. Here we go. Could not load file day3 test input. Okay, in that case, let's resort back to the thing we had before. So we'll do not read lines, but something else after I fix all of this stuff. I'll do split by new line, and then we basically have the same Same result, huh? It is really slow though. Something like that. Ah, there we already had it. It said 7. Is that what we wanted? Ah, nee. Yeah, I guess that's correct, but then we also need the same to do for this. And then what we should do is compare 1 to 0 and then keep the one which... So it is 1, huh? I guess if you calculate it, then you also know it, huh? So if we transform the 0 into a -1 and the 1 into a +1, and then sum it by that, then you know which one it is, huh? And a 0 means they're both... What should you do then? What if they're equal? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which can, I guess, happen. Why would that be? The most common second bit is 0. I feel like there might be an operation on listed. Can we just do bit calculation maybe? I don't know. Let's just try to do it like this, I guess. So we've got 1. I don't know how you call it, positive bits or something. And then this would be negative bits. And then we can compare them, and that we need to repeat per index. So the next part would be most common bit is if positive bits more than negative bits, it would be a 1, else it would be 0. And then what I think I want to do, or need to do in fact, is to repeat all of this crap per index, so per amount of characters, I guess, or bits, and then assemble a new bit number, and then transform that bit number into a decimal number. Seems like that's a plan, huh? Can we do that in one go? I think if we do... yeah, no, we can't. I was gonna say if we do a map with indexed, but... that's the other thing that I was gonna check is we could also check if this is 1. Yeah, then we would count. Maybe we can do it in the other way. So another way to do it, I think, would be to map. I think maybe we can do already with index, probably. Map indexed. I don't know why it's so slow. Ah, it's map index just like that. Bit number, and then we should just immediately check if bit number at index, well, no, if bit number I don't care about index, in fact, so silly. These, I guess I want to... Yeah. I think I'm making it really difficult on myself now. So the bit number, it's a string, normally. Now I also don't remember why I need the index even. I guess what I could do is turn this thing into a list of strings, maybe? Or a list of just regular numbers? I don't know. To int. And then every time I loop, Okay, hang on now. If I have a result list or something that I can initiate with the first one. So result, it should be a list of so it's 5 for now because they are 5 long. Yeah, and this will produce a list of integers. And maybe what I need to do, yeah, it's gonna be a little bit different. So if it equals a 1, I can just return run, and else I need to return -1. That way I can calculate them, and then I just need to apply the returned list onto the result. Bit as calculations or something, I don't know. And then I'll do result. And I think that's zip width. Is it just zip then? Yeah, zip other, zip with bit as calculations. And I think you can say how it needs to be zipped. Yeah, the transform. So I want a b, and I just want to do a plus b. Yeah? And maybe I don't want to do a map then, but a for each. Because then I can just keep on adding this thing. And then eventually my result should be this, I think. Oh, I need to reassign. So result equals something like that. And then if it's a positive one, it should turn into result map. If it is bigger than 0, then return 1, else return 0. One zero one one zero 10 110, voila. So then you can just calculate. Maybe that works better. And then we just need to turn that into a decimal number. We just need to do that. And how do we do it with the least significant bit? I guess it's the other way around then, huh? The least common bit is just the other one. So you can do the exact same thing. Isn't that just this one flipped, in fact? Yeah, it's just that one flipped. So epsilon is gamma flipped. Okay then. Maybe there is even a... No. If it 1, 0, else it should be 1. Mayung. It's not even printing it. Okay, that's fine. Yeah, do I want to? That's the question. And because I wanted to be moved to a decimal or transform to decimal, both of them. Can you do that on a... to big decimal? That's not what I want. This one we can definitely just unit test. Huh? So what I would do then is, I don't really know, do I first transform it into a string that represents the new bit number, and then I transform, so will it be string dot to decimal, or will it be a list of ints to decimal? Maybe let's do the latter, because then okay, so let's keep this part because I like it a little bit better. We need to be able to calculate with it, so let's put it into an int. And maybe if we do map indexed, so we've got the index and then the bit. And then what we should do is, if we need to check how long the list is, in fact. Or we could reverse it, maybe that'll be easier if we first reverse it. Then we'll start at the back, and then 0 will be 1, and maybe we'll do a little bit of an index to multiplier factor, I don't know. Index to so 0 would be, I feel like there's a math function for this, huh? Should be 1, 1 should be 2, 3 should be 4, 4 should be 5, no, 8. I guess it's to the power of 2, no? Well, how do you write that? Power? What the hell is this? So if I find a way to turn all of those decimal numbers to transform those decimal numbers into integers, fuck, damn it. Let's just Google a little bit. Kotlin string to bits. String representing bits. Yeah, but yeah, this. So maybe there's int from binary string or something? Tju toch. binary? Okay then, let's continue with that stuff. So I want the opposite. 2 binary. Oh, they made that themselves, okay. So Kotlin binary string to int. Oh, young. Fuck all of this fucking ads. Jesus. Maybe parse int has some options where you can say that it's binary or something. Binary to decimal. Math bow. Oh, yeah, okay. But here it's to a decimal. And I mean, that's what I wanted anyway. Oh, why is it a long? Oh yeah, because, yeah, okay. Sure, we could do that, I guess. To int radix. Let's just try that real quick. So with 2 as a radix, that's 1. Okay. What if I do that? It should be 2. This should be 4. And then this should be 8. Yay, guess what? Why was that useful again? Ah yeah, because the moment we have this, then we can count the bits. So that would be much easier. And then the next thing I can do to make this into a decimal is basically say just concatenate it all into a string and then do to int 2 and then I also have it. So if I do this dot join, that's it, using nothing. Join to string. And then say to int with 2. So if I then do gamma, wait, no, 2 decimal, my bad. Gamma 2 decimal. Let's do the same with epsilon. We've got 0 and 31. That's not what we wanted, I guess. What does gamma look like? Didn't we already check that, in fact? Hello? Yeah. Oh. It doesn't seem like this got calculated or something, I don't know. Yeah, I guess I wanted a different thing, I know. So if I wanted to get the most... Yeah, I don't think I can eventually use it, but this seems like it's a good thing to... Or this was correct, in fact. But then why is this not working anymore? So I've got the original result. Maybe I should just flip these both of them. feel like I'm gonna try this in production code or something because I don't trust the REPL for some reason. Okay, so here's our input. Oh yeah, and this is gamma. And this is epsilon. This is something we can put here. Let's see. Voila. I knew there was something wrong with the REPL. Now I just need to make this a little bit dynamic because our solve or our actual input is not 5 bits long. So maybe what we can do, how can we do that? Maybe generate. We could take the first get the length of that string and then say for 0 to gaat dat niet? Because this should generate an integer array, let's say. Yeah, voila. And we should just return 0. So now what we'll have is for 0, and maybe we should do till from 1. So 1 until string length of the first one. Yeah, okay. Okay. No, now we just need to pass the thing, the actual input in there. And see what that produces, huh? Paf. Let's see if that's correct. We have to do some Googling, Emma. It's fine, I think. Mo. Part 2. Fuck me, dude. Next, you should verify the life. Ah, we forgot the actual name. So what was the power consumption? So maybe should be get power consumption. And then let's put this in class power consumption tests. We'll nested this thing. And then the next bit would be the, not power consumption, but life support rating. Voila. And then maybe, it's already renamed, that's nice. So, and this doesn't exist yet. I guess they are not called gamma or epsilon yet, but let's find out. You should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber. So again, two things. So this is oxygen generator and CO2 scrubber. So oxygen rating, CO2 scrubber rating. Both ratings are values that can be found in your diagnostic report. Finding them is a tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with a full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Then keep only numbers selected by the bit criteria for the type of rating value for which you are searching. Discard numbers which do not match the bit criteria. If you only have one number left, stop. This is the rating value. Otherwise, repeat considering the next bit to the right. So we first want to split all of those columns into their own lists. Loop over those lists, so that's a transpose, I believe. Then loop over those lists while, or we can flatten all of those, in fact, and then and so that's taking one column after another, then transposing them into lists, and then joining them one behind the other, let's say, and then we can filter until we have one number left based on this criteria. What does that mean? You discard numbers which do not match if you only have one number left. Start with a full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Then keep only the numbers selected by the bit criteria. I don't understand the sentences. Let's just maybe find examples. The bit criteria depends on which type of rating value you want to find. To find the oxygen, determine the most common value, again, in the current bit position, and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with a 1. Here. In the position being considered. What the fuck? To find CO2, least common. Okay, for example, to determine the oxygen generator rating value using the same example diagnostic report from above. Start with all 12 numbers. So our input is 12 long, I guess. Uh, $23 in decimal. $10 in decimal. Okay. Now maybe we can write the test for this part because this is crazy, dude. Get oxygen generator rating based on this input thing. And the other one is get CO2 scrubber rating, also on the input. And then we can just generate both functions. Should return an integer. Same for this one. Yeah. And let's not make them private, but then I can unit test both of these. It's a problem, mate. Oh yeah, inner class. Returns the oxygen generator. And then I guess we want a similar one for the scrubber. Get oxygen. Okay, we've got our tests set up. So this is the first one that we're supposed to be fixing. Let's do this. Based on the criteria that they use that, I feel like the wording in this and this exercise or the puzzle is very, very specific this time. We want to filter basically. Start with all 12 numbers. Consider only the first bit of each number. There are more 1 bits than 0 bits, yeah. So keep only the 7 numbers with a 1. Ah, yeah. Now it's just not only... What the fuck? Keep only the 7 numbers with a 1 in the first position. Ah, yeah. Then consider the second bit. And then for scrubber you have to do the same, but then with least common. Okay. So that's the criteria then, I guess. In the fifth position, there are an equal number of 0 bits and 1 bits, one each. So keep the number with a 1. The biggest... Nee. So they do 5 iterations? 1, 2, 3, 4, 5 iteration, and then you've got one number. So I guess the first part is to make sure that our input based on this part here retains the ones. So we have to retain the one. And what I did was I was just calculating the amounts of ones and amounts of zeros. And now I need to know which one of these well, I guess I know which one of them is the higher, or has the higher number every time. Keep only the 4 numbers. There are 0 more bits than 1 bits. Oh yeah. Let's go back to our Scratch file. There are more 1 bits. So when we only want to keep the ones. We always only want to keep the numbers that have the most significant bits, I guess. So can we just drop that or something? How are we gonna do that? Shit. Well, there was one thing we saw. So if we do this, the do int with the radix, the moment we have this, we could do most. Nee? Something with bits. Didn't we find that? Count. Take lowest 1 bit. Take highest 1 bit. Number. Having a single bit set in the position. Yeah, maybe this is not what I wanted, in fact. Oké, wacht hè. I'm just wondering if we can use the calculation thing again. I don't think we can, in fact. Hang on. If we do it, if we first use the life support rating part. Nee, wacht hè. What was it? Power consumption, sorry. The moment we get this result, or actually this result, the actual gamma as a binary number, then you know which bits count for which index positions. So this actually can count as a criteria then. And then we can use the same for epsilon. Okay, so let's see if we can. Yeah, we can have both ratings. So if we first do, for the life support, we'll first do get power consumption based on the input, which returns a gamma and an epsilon. And the gamma, or the oxygen generator rating, should use gamma as their criteria. Fuck. Yeah, I guess what I now need to do is not return them as decimals here. So we'll go back to day 3 test and do both bit epsilon bit or something, and then we'll do gamma equals gamma bit to decimal. The hell? Oh yeah, okay. Well, what the hell am I doing? Voila. And then in my test, I will have strings, and on those strings, I'll do decimal, I guess. And then this stuff should just keep working. And then here, yeah, I'll get strings, which is great. And then these can just be criteria or something, which is a string. And both of these get that. Voila. And this we'll see if we need it or not. Voila. Then next. So our input so if we choose it to filter it once, I want to filter where my bit number, the first character equals the first character in the criteria. And I want to keep on doing that. So if this matches, we'll keep these, and then so we can do that manually. Yeah? So how do we say like stop if you found a single one? Can we take until or something? we can just loop, I guess. Okay. Bah. And we'll initialize it with this. And then we'll just do while I haven't found anything yet. Well, actually, it should be true, huh? Okay. So I should filter. Oh. Oh yeah, and then this is some index. And we need to reassign that to temp. You cannot do that. Then more than one left. We can do that. We can inline this. So this can be while TMP size is bigger than 1. We can increase the index. So the moment I only have 1 left, yeah, we can just assume that we won't get an index out of bounds and that we'll find one. Ah, no. Because the moment they are both equal in amount. Ah, nee, I need to recalculate that gamma every single time. Godverdomme, jongen. The criteria changes. So gamma changes the moment you change your list as well. So that'll become the initial criteria, I guess. Maybe we don't want that. So var criteria. It's get life support rating. Of TMP. Yeah, and then only keep gamma. Guess if I define it as a string, it might work. Oh yeah, you cannot do that. Godverdikke zeg. Wait, so what type is gamma then? An int? Maar jong, it's a... Oh, it's a get... It's the other one. Get power consumption. Yeah, that's better. So then gamma becomes this. First. Then we also increase. And then if everything is done, we just want to return the first one of this thing. And do 2 decimal or something on this. And then for the other one, we don't need this. We don't need that there either. CO2 is then the same, but instead of keeping gamma, we'll keep epsilon. So I'll just rename and then shuffle the thing we wanted to keep out of the destructuring. And here I want a second. I know there's duplication there, but let's see if this is in fact the solution. Huh? Could have kept that one test, in fact. It tests both things anyway. Guess it's incorrect. I think it has something to do with like if they're equal in that case, stuff. What about the other one? Is this one correct? No, also incorrect. Probably also has something to do with the equal thing not working. I think what I want to do is also print out the gamma every single time. If that would work. I mean, the other thing... is we could also drop the first character every single time because it's been taken care of. It might make parsing it a little bit easier. I mean, in my head, or reading it. Well, let's do that. New gamma. See, and now it would be interesting to only run this one, huh? I just threw those tests away. Godverdomme toch. Let's only run this one. And then see what the output says. Well, the good news is that it changes, huh, man? So let's keep in mind that this number 1, 2, 3, 4, 5. So it does keep it to 5, but then it's incorrect, I guess. Why though? Do we first wanna get rid of the duplication? Godverdomme. Yeah, I think if I rewrite this like this as well, then it's always the same, right? The only thing that's different is this part, the second. And we can rename this to criteria or something. So maybe if I write a function get a rating by criteria or something where I pass a list, and then a function which is basically the criteria function retriever, which is a function that takes in that same list and outputs one string, I think. This should return an int. So criteria retriever on TMP. And same here. And then this can just turn into get power consumption.tmp.first. And we'll just return get rating by criteria input, and then voila. Now we just need to make sure that it keeps I don't actually need to define it. That didn't automatically fix it, right? You never know. Oh yeah. No, at least the result is the same. I'm gonna debug. And then see, it will be also better if I output the list every single time. Maybe, wait. If I put it here, it'll be easier. And then I can also print ln. So I'll do list with criteria. And then I can just see what stuff is being kept. And then compare that to the actual what the assignment describes. Okay, so I think we're an oxygen generator rating. Great. We've already did that. Oh, fucking hell. Maybe it is better to do println. So if I step over this, I should keep 7, right? Okay, that's great. Then we increase the index. Then what? The fuck? Okay. So we have less, that's great. And our criteria has changed as well, because we want to now look at this one. So which one has the most zeros basically at the second part? So that's because we've got 1, 2, 3 with 1 out of the 7. So that means 4 zeros. So this should be 1, 2, 3, 4. So our list should slink down to 4, which it does. And then what? Now the criteria. Oh wait. Should it change in fact? Yeah, it should have. Maybe it's in this part. Let's just go check. It might just be as easy as changing the way that the criteria is gotten, because it was just if blah else that, so maybe just made a mistake there. But so for the third iteration, yeah, 3 of the 4 numbers have a 1, so keep those 3. Okay, have a 1. Yeah, it seems still like it's supposed to go that way. And then what? So out of those 3, the 4th bit should be 1s. 1, 1, 0. Here, so it's only at the 5th part where it's breaking. So this is the 5th iteration, and we're at 1, 2, 3, 4, 5, I guess. There are an equal number of 0 and 1 bits, 1 each. Yeah. And then, yeah. So to find, keep the number with a 1. So it should have been that one. Yeah, and it happens to be, so I was really lucky in fact, because temp is now only 1. Okay, so let's look at get power consumption. So if I just change this to this, then it's already good, I think. But probably for the next part, they want the equals to be zeros. Ja. Ah, godverdomme, hè. Okay, but we can say result map if it is less or equal to 0, then we want a 0, and otherwise we want a 1. And then I think that should just fix it. Now I don't want to debug anymore. The confidants. Shit. $22. So it is this one though, right? It's the CO2. Oh yeah. That seems like such a weird number. Allee, it's so different. It's only this one that I want to test now anyway. Let's run this test again. And then let's debug it again as well. We can actually see the output, so maybe if we can compare it, we can see what happens as well. Maybe I just misread it. There are fewer 0 bits than 1 bits, so keep only the 5 numbers with the 0. That's already wrong. One, 2, 3, 4, 5. Yeah. Wow, then that must mean that this is incorrect. Ah, yeah, it's the reverse. Wait, the reverse part is still the same though. So if this is 0, then 1, else it's 0. Let's rerun. Yeah, okay. My bad. So I didn't need to touch the epsilon stuff. Let's go here. Change this stuff. And then run it, baby. Nice. I wonder if these still work now as well. I mean, they should, right? Oh, okay. Cool, cool, cool. Yeah, so now I just need to do this again. I don't know about these numbers, but let's run them. Now I do realize that I have to run them multiple times. Oh, maybe I should also get rid of the alsos here. So we're first expecting 825. And then three, 3, 7, 5. And then it's just multiplying both of these numbers, which is this number. Let's see if that's indeed correct. Dude, it's correct. We did it! Okay, let's read the fourth one. I don't have time for that today anymore. The giant squid. Oh boy. Oh boy, oh boy, oh boy. Then this is just the first thing. Oh. Oh, here you want to check which numbers are there or what? Really, you're already almost 1.5 kilometers below the surface of the ocean, already so deep that you can't see any sunlight. What you can see, however, is a giant squid that has attached itself to the outside of your submarine. Maybe it wants to play bingo. I think it wants to play... Yes, dude, Advent of Code, here we go. I just finished day 3. And I haven't done a refactor yet to make it a little bit nicer. But we've got working code, so I'm glad. Try hack me, Advent. Oh no. If it's even kicking Breeze Lou in the balls, then I don't know. I don't know if I'm gonna be able to. I guess I'll wear my guard. We can play bingo with the giant squid. It automatically generates a random order in which to draw numbers and a random set of boards. Here's the example. Oh yeah, so these are all different boards split by a new line. So parsing this is gonna be fun. And then these are the numbers that are being drawn. After the first 5 numbers are drawn, there are no winners, but the boards are marked as follows. Shown here adjacent to each other, safe space. After the next 6 numbers are drawn, there are still no winners. Finally, 24 is drawn. These, I don't know if it matters in how many numbers or something like that, but the third board wins because of that, at least one complete row or column marked numbers. The score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on a. The sum is 188. Then multiply that by the number that was just called when the board won. Jesus Christ. To guarantee victory, figure out which board will win first. Huh? Okay. I guess we'll need to keep a list of boards. And then keep a duplicate of rows and columns or something. Probably be easiest. And then when a number is being drawn, just loop over all of the rows and all of the numbers and then flip a toggle basically. And then number of all unmarked numbers, then that one we can just do by looping over all of the rows, getting all of the unmarked ones, sum them, and multiply that by the last number. And that we have to do for every board. Okay. And is it always 5 by 5? What does the puzzle input look like? Are these 5 by 5 boards? Yeah, okay. But then plenty of boards apparently. Fuck me, dude. Yeah, I think it will be okay. That will solve with some types, I think, but so not today, I'm afraid. Because I have to eat. Let's make a little commit. Little commit, yes. Solve day 3. I had 0 intermediary commits. Let's go back to our solution. What does it look like? This can be private. We don't need this. I mean, it's quite concise. I feel like this I can improve, but I don't know what the functional way to do that is. I guess it could be a reduce with index because I keep changing the... I keep reducing on the list. And if I have one left, then I need to stop. So maybe... I mean, but what's the use? This is fine, eh? No? No. So it was just important for oxygen to use the gamma result as a criteria. And then for scrubber, it should have used the epsilon as a criteria. And then the way I get to gamma and epsilon is by just calculating the bits on top of each other. And if it was a positive or a 0, 1, then you'd have a 1, and otherwise you'd have a 0. In retrospect, it's quite easy, but the way that it took me 2 hours to get to this point. So all right, cool. Hopefully see you tomorrow, I think. It should be somewhere around like in the afternoon. because I need to be my family at 4:30, in fact. So yeah, maybe start at lunchtime or something. I don't know. Anyway, if you want, then join me tomorrow. Give me a follow if you like, and then you'll be notified. And until then, have a nice Saturday evening, and GG's. Wish I had that button with me right now. Could scream GG. Alright, thanks for hanging out, and maybe see you tomorrow. In the meanwhile, also have a nice, or have good luck with your Advent of Code solutions. I'll still need to commit and push. Commit. And then push. Okay. Alright, was nice. See you tomorrow. Yo, yo, yo. Peace, peace, peace. Bye, bye, bye. Yo.
Keeps luring in like a pack of snakes. You're sweet.